So this problem here is based off of the demo I did in class last week where I had copper flakes reacting with silver nitrate. If 0.50 grams of copper wire reacts with 1.59 grams of silver nitrate to form pure silver metal and copper nitrate, A, what mass of silver metal is expected? B, what mass in grams of the excess reactant remains when the reaction is complete? And C, what is the percent yield of silver? So our first step is to write the balanced chemical equation. So we have copper wire, which is solid, reacting with silver nitrate, which is aqueous, to form copper to nitrate. So that is aqueous and silver metal. Now looking at this chemical equation, it is not balanced because in the products we have 2 nitrate ions, but in the reactants we only have 1. So I add a 2 in front of silver nitrate. But now I have 2 silver atoms and only 1 in the product. So I add a 2 in front of silver. And now our chemical equation is balanced. Now, question A is asking us what mass of silver metal is expected. Since in this problem it gives us the mass of 2 different reactants, so copper and silver nitrate, we know that this is a limiting reactant problem. So the problem already gives us that we have 0.50 grams of copper. Since this is a limiting reactant problem, we will need to convert to moles of copper. So I look at the periodic table and find the molar mass is equal to 63.55 grams per mole. The problem also tells us that we have 1.59 grams of silver nitrate, and the molar mass of silver nitrate is equal to the molar mass of silver, which is 107.87, plus the molar mass of nitrogen, which is 14.01, plus 3 times the molar mass of oxygen, which is 16.00. We add that all together and we get a molar mass of 169.88 grams per mole. So question A is asking us what mass of silver metal is expected. Since this is a limiting reactant problem, we're going to convert both the mass of copper and the mass of silver nitrate to mass of silver. And whichever value is lower will tell us what mass of silver is expected. So we have 0.50 grams of copper. We're going to use the molar mass to convert from grams of copper to moles of copper. Grams will be in the denominator, so it cancels out, and moles will be in the numerator. And we put the molar mass, 63.55, in the denominator. It is next to grams in the molar mass, so we keep it next to grams in our fraction for 1 mole. Now we will use the mole ratio to convert from moles of copper to moles of silver. So we have moles of copper in the denominator so that it cancels out, and moles of silver in the numerator. When we read the balanced chemical equation, we have 1 mole of copper reacting to form 2 moles of silver. And so we have 2 moles of silver forming from 1 mole of copper. Now that we have moles of silver, we can use the molar mass to convert to grams of silver. Moles are going to go in the denominator, grams in the numerator. And I just look at my periodic table or in the calculation I did above. The molar mass of silver is 107.87 grams per 1 mole. And I put that in my calculator and get an answer of 1.6974 grams of silver. Now that I've converted from grams of copper to grams of silver, I need to do the same for silver nitrate. So we started with 1.59 grams of silver nitrate. To convert to moles of silver nitrate, we use the molar mass. Grams are going to go into the denominator so that they cancel out. Moles in the numerator. And we look up, and our molar mass is 169.88 grams per mole. 169.88 grams per 1 mole. To convert to moles of silver, we're going to use the mole ratio. So we have moles of silver nitrate in the denominator, so they cancel, and moles of silver in the numerator. We read the balanced chemical equation. We see that 2 moles of silver nitrate react to form 2 moles of silver. So we add that in our mole ratio. Now to convert to grams of silver, once again we use the molar mass. So 107.87 grams per 1 mole. Put that on my calculator and I get an answer of 1.0096 grams of silver. So looking at my 2 final answers, I see that silver nitrate produces the least amount of silver. Therefore, silver nitrate is the limiting reactant, copper is the excess reactant, and 1.0096 grams of silver is expected. So I'm going to write a brief statement. Therefore, 1.01 grams of silver is expected. Now remember, I leave more significant digits than needed when I'm doing a limiting reactant problem, just in case if the correct number of significant digits is not enough precision to determine which reactant is a limiting reactant. Now, our next question is asking what mass in grams of the excess reactant remains when the reaction is complete. So we determined that copper is the excess reactant, silver nitrate is a limiting reactant. So for B, we're trying to determine how much copper is left over after all 1.59 grams of silver nitrate reacts completely with copper. To do this, we are going to convert from the expected mass of silver back to grams of copper, and then we are going to subtract that mass from the initial mass of copper, and that should give us the excess amount of copper that remains once the reaction is complete. So for B, I have 1.0096 grams of silver. I'm going to use silver's molar mass to convert to moles of silver, grams on the bottom, denominator, and moles on the top in the numerator. The molar mass of silver is 107.87 grams per 1 mole. Then I'm going to look back at my balanced chemical equation and use the mole ratio to convert to moles of copper. So we have moles of silver in the denominator, moles of copper in the numerator. I see that 2 moles of silver are produced when 1 mole of copper is reacted. So I have 2 moles of silver for every 1 mole of copper. And now that I have moles of copper, I'm I'm going to multiply by the molar mass to get grams of copper. So moles goes on the bottom, grams on the top, the numerator. The molar mass of copper is 63.55 grams per 1 mole. And I put that all in my calculator and get a mass of 0.2974 grams of copper. Now our initial mass of copper was 0.50 grams, and only 0.2974 grams of copper are being used up. Give myself some more space. So we have initial mass of copper is equal to 0.50 grams. Mass of copper reacted is equal to 0.2974 grams. Now, when I subtract 0.2974 from 0.50, I get an answer of 0.20 grams. Now, remember when we were doing subtraction, the correct number of significant digits is the least amount of points after the decimal. So we have 2 places after the decimal for our initial mass, and for our calculator answer we had 4. Therefore, we stick with 2 in our final answer. Now I'm going to write a brief statement. Therefore, 0.20 grams of copper is left over. Now question C is asking us, what is the percent yield of silver? So the equation for percent yield is, percent yield is equal to actual yield over theoretical yield times 100. So the theoretical yield, which we have already calculated, is the hypothetical yield that we would isolate in the lab. So if we scroll up, we determined that the expected mass of silver would be 1.0096 grams. Therefore, our theoretical yield is 1.0096 grams. And the actual yield is determined experimentally. So I did this demo for the class last week sometime. In my notebook, I recorded the mass of the weigh boat that I used to collect all of the silver metal from the reaction. A weigh boat is just a plastic dish. They're usually white in color, and it's something that you would use in a lab just to collect any product or weigh any product on a balance. And the mass of the weigh boat was 2.29 grams. Then I scraped the silver metal from the filter paper that I used in class into the weigh boat and got a mass. So the mass of the weigh boat plus product was equal to 2.96 grams. Now to determine the mass of my product, so mass of product, I subtract the mass of the weigh boat from the mass of the weigh boat and the product, and I got a mass of 0.67 grams. So that means that my actual yield for this reaction was 0.67 grams of silver. So moving on to the percent yield calculation, I have my actual yield, which is 0.67 grams of silver, divided by my theoretical yield, which would be 1.0096 grams of silver. Multiply that by 100. And I put that all in my calculator and get an answer of 66%. Now for question C, I'm going to write a brief little statement. Therefore, the percent yield of silver was 66%. In an ideal world, my percent yield should be 100%, but there are a few sources of error that result in a lower yield. So first of all, the reaction took place on the surface of the copper metal. If you remember, I had those thin copper sheets in the solution in the Erlenmeyer flask, and I might not have left enough time for all of the silver nitrate to react with the copper. Another source of error for this reaction is that I used tap water instead of deionized water. So as many of you know, water from the ground contains minerals, and since the water that I got for this reaction came from the city has various water treatment plants where they have to put ions and chemicals in the water to help treat it for bacteria and other different pathogens. So if I had to use distilled water, which is hypothetically free of any ions, or you could go a level above that, which is ultra pure water, which is used in analytical chemistry labs, there would be less chance for these ions to react with the copper or the silver nitrate and result in a higher yield. One of the more obvious sources of error is that I was most likely not able to transfer all of the silver metal to the filter paper when I filtered this reaction. I think I showed you guys in class, but after I transferred the solution to the filter paper, there was still some silver metal left over in the flask. Then, after I let the silver metal dry overnight, I scraped it from the filter paper to my pre-weighed weigh boat. So there was some silver left over on the filter paper. So that is another source of error for why I got a lower yield. In the lab you guys are doing on Monday, you are asked to weigh the filter paper before you do the filtration. Therefore, you will have a more accurate yield, since you do not have to transfer or scrape your product from the filter paper to another weigh boat. As you can see, these problems can be a bit time consuming. Question A relates to 27 to 30 on page 134. Question B similarly is from questions 27 to 30. And question C is actually a part of the next section, but I thought it would be useful to introduce you to percent yield as it will be applicable to the lab you are doing on Monday.